Hi everyone, welcome to Calculus Made Simple by Dr. C, and that's me. I have a new set of videos out to teach you the essentials of Calc 101. You will learn what to expect, how to do it, and be prepared for success in your Calc 101 class. Watch my videos. In Lesson 1, we're going to talk about limits, the practical aspect of them. We're going to talk about derivatives, and we're going to talk about integrals. Please click the like button to get more content and essential tutorials. Hi, I'm Dr. C, and welcome to Calculus Made Simple. Today we're going to talk about derivatives in Lesson 1b. Consider a line as shown in Figure 1.2, where f of x is equal to 2x. This is a line with a slope of 2. The slope is delta y over delta x, and it's equal to 4 divided by 2, which is equal to 2. And the slope formula, if we get into this represented by a function value, the function f at x plus delta x is this value here at this point, minus the function of x, which is this value of y. So we get really delta y is f of x plus delta x minus f of x, and then we divide by delta x. So that's a more detailed expression, and this gives us the slope for the line everywhere. In this case, since it's a straight line, the slope is constant, it's equal to 2. So let's evaluate the slope m. We take the function 2, evaluated at x plus delta x, subtract off the function f of x, which is 2x. We see that the 2x's cancel, and we're left with 2 delta x, and we divide by delta x, which is equal to 2. In this slide, we're going to talk about what happens when we compute the slope of a tangent line to a curve, meaning we don't have a straight line. So consider the case where we have f of x is equal to x squared. This is a parabola, and we see that it's drawn here in Figure 1-3. At x equal 1, we see the value of y is equal to 1. So let's see, what if we apply the straight line formula for a point on the curve at x? We see that m of x is equal to f of x plus delta x minus f of x divided by delta x. And if we do that at x equal 1, we see that the straight line curve slope gives us delta y over delta x, which is 2. Well, we don't have a straight line. This doesn't represent the slope, but the slope at that point at x equal 1 is this tangent line. So we can see that if we evaluate the slope in the limit as delta x approaches 0, we do get the slope of the tangent line to the curve at x equal that value. So in this case, we write this as dy dx, meaning it's a delta over delta x, delta y over delta x, but it's really, really small in the limit as delta x approaches 0. So we just use the d value, dy dx for the slope, and we take the limit as x approaches 0 of m of x, and that gives us 2 as we evaluate it up here in 1.4a. And we can see that the slope of this tangent line to the curve at x equal 1, using the normal slope formula, delta y over delta x, is equal to 2 over 1, which is equal to 2. In wrap up, we see that for y is equal to f of x, the instantaneous slope of a tangent line to the curve is called the derivative. We write that as dy dx or df dx, and it's defined in the limit as delta x approaches 0 of m of x, where m of x is f of x plus delta x minus f of x divided by delta x. And we put that all together, and we get dy dx is equal to the limit as x approaches 0 of f of x plus delta x minus f of x divided by delta x. That's our derivative with respect to x. All right, everybody, thanks for watching. We presented conceptual and mathematical explanation. Simply apply the formulas with the information in the problem-solving statements to get your answers. Check out our teaching assistant problem-solving sessions. And if you like this content, found it useful, please click the like button and subscribe as well. And check out subsequent lessons in the links below. Thanks for watching.